Welcome to month 1 of the architect track. If the tech-led track was about making decisions within a system, this track is about making decisions about systems, the boundaries, the integrations, the governance that shapes how an entire engineering organization builds software. Architecture is the dividing line between senior engineer and architect. It's not about writing better code. It's about designing systems where teams can write code independently and ship reliably. Every company reaching Series B and beyond needs someone who can draw the boxes, define the boundaries, and make the trade-offs explicit. That's the role you're stepping into. Today, we're designing a real fintech platform, the kind of system you'd whiteboard in an architect-level interview at Stripe Square or Plaid. Here's what we're covering: 4 hours, 4 outcomes. First, the domain. We're designing for a fintech company called FinFlow. Second, the approach, C4 modeling, which gives us a shared visual language for architecture. Third, the challenge. You'll produce 5 real deliverables by the end of today. Fourth, the twist. There's a cognitive exercise on stakeholder alignment, because architecture is as much about people as it is about technology. This isn't a lecture and listen session. You're producing real work product. Let's walk through each objective and why it matters. First, C4 model architecture. If you ask 10 architects to draw the architecture of the same system, you'll get 10 completely different diagrams using 10 different notations. C4 gives us a shared language. After this session, when someone says container diagram, everyone will picture the same thing. Second, integration patterns. FinFlow has over 500 external integrations. The current team built them point to point, each one a bespoke snowflake. We're going to design a strategy that handles 500 integrations without 500 different patterns. Third, API strategy. A real API strategy isn't just we use REST. It's we use REST for external APIs because of ecosystem tooling, gRPC for internal services because of latency, and we've evaluated GraphQL for specific dashboard use cases. That's what we'll build today. Fourth, governance frameworks. Governance has a bad reputation. It conjures images of review boards that block progress. Good governance is the opposite. It's the guardrails that let teams move fast without stepping on each other. We'll design governance that accelerates, not decelerates. Fifth, stakeholder element. The best architecture in the world dies if the security team blocks it, the executives won't fund it, or the developers refuse to adopt it. Stakeholder alignment is the soft skill that makes the hard skills matter. K4 is the work of Simon Brown. It stands for context, container, component, code, 4 levels of zoom, like Google Maps for software. Level 1 is system context. This is the 10,000-foot view. Your system is one box in the center. Everything around it, users, external systems, regulators, are other boxes. The arrows show who talks to whom. The audience for a context diagram is non-technical stakeholders. Your CEO, your compliance officer, a new engineer on their first day. Anyone who needs to understand what the system does without knowing how. Level 2 is container. Now we zoom in. The single FinFlow box splits into its major runtime components: web apps, APIs, databases, message queues, caches. A container in C4 is not a Docker container. It's any separately deployable unit. A microservice is one type of container. But a container can also be a single page app, a database, a batch job, or a message queue. C4 is technology agnostic. The audience for this diagram is the development team. It answers, what do we deploy and how do the deployments talk to each other? Level 3 is component. Zoom into one container. Show its internal structure, the modules, services, controllers, and engines. This is where you document security boundaries, internal patterns, and component responsibilities. Typically, you only create level 3 diagrams for the most complex or critical container. For FinFlow, that's the payment service, because it's in PCI DSS scope and handles the most complex business logic. Level 4 is code. Class diagrams, essentially, usually generated from code, not hand-drawn. We won't create level 4 today. It's only useful for very complex modules where the code structure isn't obvious from the level 3 diagram. Think of it exactly like Google Maps. Level 1 is the country, you see cities. Level 2 is the city, you see neighborhoods. Level 3 is a neighborhood, you see streets and buildings. Level 4 is a building, you see the floor plan. You choose the zoom level based on what question you're answering. FinFlow's number one pain point is point-to-point integrations, creating maintenance burden. That means every external integration was built as a custom one-off. When Stripe changes their API, one team scrambles. When a bank changes their file format, another team scrambles. There's no strategy, just survival. We're going to fix that. Here are the 5 patterns you need to know. First, API gateway, the front door. All external traffic enters through one point. This is where you apply rate limiting, authentication, SSL termination, and request routing. Without it, every service handles its own rate limiting inconsistently. Second, event driven. Asynchronous, decoupled communication via a message broker. Service publishes an event. Payment succeeded. Services B, C, and D subscribe and react independently. The publisher doesn't know or care who's listening. This is the answer to FinFlow's coupling problem. Currently, when a payment succeeds, the payment service directly calls the notification service, the accounting service, and the analytics service. If any one of them is slow, the payment response is slow. Events break that chain. The trade-off is eventual consistency. When payment service publishes payment succeeded, the notification service might not process it for 500 milliseconds. The payment is confirmed, but the email hasn't sent yet. For most fintech use cases, that's acceptable. Third, ETL and batch, scheduled large volume data movement. Bank H files are inherently batch. They're processed in Windows typically 3 times a day. Reconciliation is also batch. You compare yesterday's transactions across systems nightly. Don't try to make batch real time. Some things are batch because the external system is batch. Accept it. Fourth, service mesh, service-to-service communication management. Tools like Istio or Linked sit as a sidecar proxy next to each service. They handle mutual TLS, encrypted communication between services, traffic routing, retry policies, and observability. For PCI DSS, service mesh is almost mandatory. Requirement 4. One says encrypt all cardholder data in transit. Mutual TLS achieves that without each service implementing TLS manually. Fifth, circuit breaker. When an external system is failing, stop calling it. A circuit breaker tracks failure rates. After n failures, it opens. All subsequent requests immediately return an error or a fallback without attempting the call. After a timeout, it half opens. One request goes through as a probe. If it succeeds, the circuit closes. Without circuit breakers, one slow external provider can cascade failures through your entire platform. Stripe has an outage. Without circuit breakers, every payment request blocks, waiting for Stripe's timeout, exhausting your connection pool, causing your system to appear down. When choosing a pattern, evaluate 4 dimensions. Latency requirement. Does the user need a response in under 2 seconds? Then it's synchronous. Coupling need. Should the sender know about the receiver? If no, use events. Data volume. Is it a million records at once? That's batch or ETL. SLA target 99. 99% availability means circuit breakers and fallbacks everywhere. API strategy isn't pick one protocol. It's pick the right protocol for each use case, then govern it consistently. Let's walk through each option. REST is the lingua franca of the web. Every developer knows it. Every tool supports it. For external facing APIs, where your customers integrate with you, REST is the default choice. The design decisions matter more than the protocol. A well-designed REST API with consistent naming, clear error responses, and proper pagination is 10 times better than a poorly designed GraphQL API. GraphQL excels when clients need flexibility. A mobile app wants 5 fields. A dashboard wants 50 fields. With REST, you either create multiple endpoints or overfetch. With GraphQL, the client specifies exactly what it needs. But GraphQL has costs. Query complexity attacks. A malicious query can join 10 levels deep and bring down your server. Schema governance. Who owns which types? And caching is harder since every query is unique. So CDN caching doesn't work as well. For FinFlow, GraphQL makes sense for the customer dashboard, where different customers want different views of their data. It does not make sense for payment processing. Those are simple write operations. For service-to-service communication inside your mesh, gRPC is 2 to 10 times faster than REST because it uses HTTP or multiplexing and header compression and protocol buffers for binary serialization. The schema is defined in proto files, which generate client and server code automatically. The downside: browser support is limited and it's less human readable than JSON. But for internal services where performance matters and both sides are your code, gRPC is the winner. The real strategic question is not REST or GraphQL or gRPC. It's where do we use each and how do we ensure consistency across all three? Your API standards document should answer naming conventions, versioning strategy, error formats, and they should be consistent whether the underlying protocol is REST, GraphQL, or gRPC. Okay. This is the challenge brief. Read it like you'd read a real project kickoff document. Platform: B2B payment processing, not consumer. This means your customers are businesses. They integrate via API, and their tolerance for downtime is measured in dollars per minute. Scale: 1 million daily transactions isn't Visa scale, but it's enough to break a naive architecture. 500 API integrations means you can't handcraft each one. 10,000 business customers means multi-tenancy per customer rate limiting and SLA tracking, compliance. This is the part that makes fintech architecture hard. PCI DSS level 1 means annual on-site assessment by a qualified security assessor. Every design decision you make will be scrutinized by auditors. SOC 2 typicity means demonstrating security controls over a 6 to 12-month period. GDPR means EU data stays in the EU. The pain points are real. First, a monolithic legacy system, 15 developers blocked by one deployment pipeline. Second, point-to-point integrations, 500 bespoke integrations, each with its own error handling. Third, inconsistent APIs. Team A uses camel case, Team B uses snake case, Team C uses snake case, Team C uses XML. Fourth, no formal architecture review. Anyone can add a new database, a new language, a new framework. If tech debt accumulating, because without governance, every shortcut becomes permanent. Your job is to design the architecture that solves all five. This is the biggest deliverable. You're creating 3 levels of C4 documentation. Level 1, system context. FinFlow in the center, around it. Business customers, internal users, banks, payment networks like Stripe, data providers like Plaid and credit bureaus, KC providers, accounting software, and regulators. Show every external interface with a labeled arrow. Protocol, direction, and what data flows. A common mistake is forgetting the regulators. FinFlow doesn't just receive data from them. It sends compliance reports, audit logs, and suspicious activity reports outbound. Level 2, container. You'll need a minimum of 12 containers. Think about it. Web apps for different user types, an API gateway, backend services for payments, accounts, compliance, notifications, and reporting, plus databases, cache, event bus, and search or analytics. You'll easily hit 12 to 15. The key question is, how do you decide where to draw container boundaries? The answer is domain-driven design. Each bounded context becomes a container. Payments is a domain. Accounts is a domain. Compliance is a domain. Compliance is a domain. If 2 things change together, they're in the same container. If they change independently, they're separate. Level 3, payment processing. Zoom into the payment container. Show the internal components: API controller, payment orchestrator, card processor, ACH processor, tokenization engine, fraud detection, and settlement engine. Mark the PCI DSS security boundary explicitly. This boundary determines what's in scope for audits. Every diagram needs a legend. Every major decision needs a rationale. We chose Kafka over RabbitMQ because of X, Y, Z. If you can't explain why, you haven't made an architecture decision, you've made a preference. 6 external system categories, 6 different integration designs. Stripe with a 99% SLA. This is your highest SLA dependency. If Stripe is down, your customers can't process payments. Think about idempotency keys, webhook signature verification, and circuit breakers. Red with 1 million calls per day. Highest volume, account aggregation means pulling transaction history for thousands of bank accounts. Webhooks for incremental updates, cursor-based sync for consistency. Banks via SFTP. The oldest pattern in the room, page transfers are file-based. Nasha format files uploaded via SFTP. Batch processing, not real-time. Credit bureaus at 50,000 calls per day. Synchronous request response. The interesting part is multi-bureau strategy. Which bureau do you query first? What's the failover? How do you comply with FCRA? Cursey providers. Async by nature. You submit documents, they take hours to verify. Designed for the callback pattern. Accounting software at 100,000 calls per day with a 99% SLA. Lowest SLA requirement. Real-time sync for transactions, nightly batch for reconciliation. Opt to for each provider. Don't just draw arrows between boxes. Design the infrastructure. The message bus. How many topics? What's the partitioning strategy? What's the retention policy? Error handling. Classify errors as transient, meaning retry, or permanent, meaning sent to a dead letter queue. Define retry policies per provider. Circuit breakers. What threshold opens the circuit? How long before half open? And monitoring. What alerts fire when a provider is degraded? 20 minutes, 2 columns. This is about creating a reference document, the kind of thing you'd hand to a new team joining FinFlow and say, follow this. The left column covers REST standards. Cover the basics that prevent inconsistency. Snake case everywhere, plural nouns for collections, cursor-based pagination. Not offset, standard error response body, and rate limiting tiers. A good API standards document isn't long. It's decisive. Don't say, consider using pagination. Say, all list endpoints must use cursor-based pagination with a default limit of 20 and a maximum of 100. The right column covers GraphQL, gRPC, and versioning. Evaluate GraphQL. Don't just say yes or no. Identify specific use cases where it adds value, like dashboards and mobile, and where it doesn't, like payment rights. For gRPC, define proto-file organization. For versioning, pick a strategy and commit. URL path versioning for REST, package versioning for gRPC, and define the deprecation timeline. The goal is to create a standards document that any team at FinFlow can reference. If it doesn't answer a developer's question within 30 seconds of scanning it, it's too long or too vague. Governance is the part most architects skip and then wonder why teams don't follow the architecture. You need a minimum of 10 architecture principles. Architecture principles are not aspirations. They're constraints that shape decisions. Each principle needs 3 parts. A statement, what we do, clear and unambiguous. A rationale, why we do it, tied to a business need or regulatory requirement. And the implications, what this means for teams, specific and actionable. For example, security by design means every new service goes through threat modeling before development starts, not after. Event-driven by default means you need a justification for synchronous calls, not for async ones. Next, define your tech standards. This is the approved technology list. Approved doesn't mean mandated. It means use these unless you have a compelling reason not to. The point isn't to restrict innovation. It's to prevent a polyglot mess where every team uses a different database, framework, and language. Then define your review process. When is architectural review required? New service? Yes. New external integration? Yes. Bug fix? No. Feature flag change? No. Make the threshold clear so teams don't game it or get blocked unnecessarily. The architecture review board isn't a gatekeeper. It's a peer review. The board includes rotating engineering representatives, so it stays grounded in reality. Every principle follows the same 3-part structure. No exceptions. Consistency in governance documents is as important as consistency in APIs. Architecture doesn't exist in a vacuum. Every design decision has stakeholders with competing interests. This exercise forces you to think about the people side of architecture. Here's the scenario. You've designed a beautiful microservices architecture. Now you need to sell it. 6 stakeholder groups will have opinions, and some of those opinions will conflict. Executive leadership. They care about cost and speed. How much does this migration cost? And when do we start seeing ROI? If you can't answer these, your architecture is a PowerPoint, not a plan. The security team. They push back on microservices. More services means more attack surface. Their concerns are legitimate. We need to show how service mesh, network segmentation, and centralized logging actually improve security posture compared to the monolith. Operations. More services means more things to monitor, more things that break at 3 a.m. If you don't address their concerns about observability and on-call complexity, they'll become a political blocker. Development teams. They want autonomy and velocity, but they also need to learn new patterns, event-driven, Kubernetes, Go. Factor in the learning curve. The first 3 months will be slower, not faster. Product management. They want features, not infrastructure. The migration competes with the roadmap. Show them how migration enables features. For example, microservices let you A/B test payment flows independently. Customers, they don't care about your architecture. They care about API stability, latency, and uptime. The migration must be invisible to them. 0 breaking changes, no downtime. The exercise has 4 tasks. First, identify 3 concerns per group. Be specific, not generic. Second, find 5 conflicts where group interests clash. Third, develop resolution strategies for each conflict. Fourth, create an alignment matrix, a visual showing where each group stands on key decisions. The most common clashes are executives versus security on speed versus thoroughness, developers versus governance on autonomy versus standardization, and product versus engineering on features versus migration. There's no single right answer. The point is identifying the conflicts before they ambush you in a meeting. 5 deliverables, all due by end of session. Deliverables 1 and 2 are visual plus written diagrams with accompanying documentation. Deliverables 3, 4, and 5 are pure markdown documents. For time allocation, you have about 120 minutes of hands-on time. The suggested breakdown is 45 minutes on C4, since it's the most complex and the highest weighted. 35 minutes on integration design, 20 minutes on API standards, and 20 minutes on governance. The stakeholder analysis is a separate 20-minute exercise. If you're running behind, prioritize depth over breadth. A detailed C4 with thorough integration design scores higher than 5 shallow deliverables. Here's how the work will be scored. Notice the weighting, C4 documentation at 25%. The heaviest weight. All 3 levels are expected with correct notation and documented decisions. A level 2 diagram without a legend or without labeled communication protocols loses points. Integration design at 20%. Pattern selection with rationale. Don't just say event-driven, say event-driven, because the accounting sync can tolerate 30 seconds of eventual consistency, and we need to decouple the payment service from the sync service. Error handling strategy is mandatory. API strategy at 15%. Completeness matters. Cover all 3 protocols. Define versioning. Include examples. A standards document without examples is a wish list. Governance framework at 15%. A minimum of 10 principles, each with a 3-part structure. Tech standards must be decisive, not vague. Stakeholder analysis at 10%. Specificity is key. Executives care about cost is obvious. Executives need a 3-year TCO comparison showing break-even at 18 months is useful. Presentation quality at 10%. Can you explain your architecture in 8 minutes? Can you defend your decisions under questioning? Clarity and confidence matter. Peer review at 5%. Constructive feedback is part of the architect role. Passing threshold is 70%. Excellence is 85% and above. These are stretch goals between sessions, not created, but then make you significantly stronger. Design 3 enterprise architectures. Pick 3 different domains: healthcare, e-commerce, logistics. Each has different compliance requirements, scaling patterns, and integration challenges. Practice the process, not the tools. Study enterprise integration patterns. OpenWolf's book is the definitive reference. It's from 2003 and still completely relevant. Patterns like message router, content-based router, and dead letter channel. You'll see them in every modern event-driven system. Create a reference architecture. Apply C4 modeling to your own company. This is the highest value exercise because you'll discover gaps in your own understanding. Read Fundamentals of Software Architecture by Richards and Ford. This is the textbook for this track. Focus on the chapters on architecture characteristics and component-based thinking, present to executives or market. The presentation skill is as important as the design skill. If you can't sell your architecture to non-technical stakeholders, it won't get funded. Practice with a friend playing the skeptical CFO. Build an architecture review process. Document a real review process for your organization. When is review required? Who sits on the board? What are the decision criteria? 3 required books, 2 online references, and 4 tools. Fundamentals of Software Architecture is your primary textbook for the entire architect track. Read part 1 on architecture, thinking before month 2. The C4 Model website at C4 Model, website at C4 Model. Com has examples, templates, and a clear explanation of the notation. Bookmark it. Structurizr lets you define C4 models as code. Your architecture diagrams live in version control alongside your source code. The Enterprise Integration Patterns website has all the patterns from the book free. Use it as a reference when designing your integration architecture. Let's review the time blocks. Spend about 40 minutes on introduction. Next is 20 minutes on the cognitive exercise for stakeholder analysis. Then 110 minutes of focused hands-on work. Finally, 60 minutes of presentations and peer review, 8 minutes per person or group, followed by structured feedback. Some common questions that come up. Can I use draw? IO, or should I use text-based diagrams? Either is fine. Draw. IO gives nicer visuals. Text-based options like Mermaid or Structurizr DSL are more version control friendly. Choose what lets you move fastest. Should the C4 Level 3 cover the entire payment service or just one flow? Show all components, but you can highlight one flow. For example, card payment authorization in detail. The goal is to demonstrate that you understand the internal structure. How specific should the governance principles be? Specific enough that a developer can use them to make a decision without asking an architect. Design for failure is vague. All services must implement circuit breakers on external calls with a 5 failure threshold is actionable. What level of detail for the integration error handling? At minimum, error classification, transient versus permanent, retry policy per provider, max retries, back-off strategy, and what happens when retries are exhausted, dead letter queue, alert, or fallback. For the API strategy, do we need to design actual endpoints? No. Design the standards that govern endpoint design. URL naming convention, error response format, pagination approach. Include examples, but don't design the full API. Good luck with the challenge. Focus on trade-off documentation. I chose X because of Y. Accepting the cost of Z is the hallmark of architectural thinking.